Happy Friday. We are going to take what hopefully we learned on Wednesday and expand on it a little bit, simplifying radicals that are not perfect squares or perfect cubes necessarily. We're also going to learn how to add and subtract and multiply some radicals together. I've shortened your homework assignment because I didn't want to get into some of the more complicated problems, so I'm actually going to split 7.2 up into 2 days, and I will be back with you on Tuesday. If you have questions on your homework, please feel free to hold on to them, and I will answer them all on Tuesday. So, it's perfectly okay. So our first example is square root of 72. And if you remember from yesterday, you should be able to pull out your 7.1 and look at all those perfect squares, looking for numbers that in that group of your squares that go into 72, because 72 is not a perfect square. So if you found it, hopefully you found that it's 36. So we're going to rewrite 72 as 36 times 2. And then we're going to use this little property right here that lets you split that into square root of 36 times square root of 2. And the square root of 36 is 6. And the square root of 2, because it's not a perfect square, has to stay under the radical. So there's our first example. The next one is a cube root. And it also has some x and y's in it. So we're looking, find that column of your cubes. We're looking for numbers that divide evenly into 24 that are perfect cubes. And that's going to be your 8. So I'm going to rewrite this cube root of negative 8 times 3 times x cubed times y, this is, you have cubed y squared. So I took that 5 and I split it up into 3 plus 2. Alright, so we've got cube root of negative 8, cube root of 3, cube root of x cubed, cube root of y cubed, and cube root of y squared. So these are the two little guys that aren't a cube. So they're going to stay under the radical. Everything else is going to come out in front. So the cube root of negative 8 is negative 2. The cube root of x cubed is x. The cube root of y cubed is y. And then we're going to rewrite the radical with the 3 and the y that were left over. So those are what kind of the complicated ones look like. Let's do another one. We've got square root of 60, x, y to the 7th, z to the 8th. And there's a couple of ways that we could look at this. Let's take a look at our 60. We're looking for numbers that go into 60 that are a perfect square. It may take you a little bit of time. Obviously, you're not starting with 81 won't go in, 49 won't go in, 36 won't go in. We're kind of having problems finding something until you get to 4. So 60 can be split into 4 times 15. And then let's go ahead and split this as we go. Then we'll have the square root of x, the square root of y to the 7th, and the square root of y to the 9th. Now, if you look at this and split it even further, we're going to have the square root of 4, the square root of 15, the square root of x. Let's see how many y's we can get out. We have the square root of y squared. There's 2, 4, 6, and 1 left over. Ooh, that was supposed to be a z right there, sorry. Z to the 9th. There we go. And then with our z's, we have a square root of z squared. So there's 2, 4, 6, 8, and there's our leftover 9. So our perfect squares, here's our first one. It's 2, and then The square root of y squared is y, and we have 3 of those, so that's y cubed. So they're gone. We have the square root of z squared, and we have 4 of those. And then what's left under the radical? There's our 15, our x, here's a y, and last but not least, a z. Okay, adding and subtracting. You can add and subtract radicals as long as they're the same radical. Not only like the square root and square root, but you can combine cube root of 2 here. So we've got 1 cube root of 2 plus 5 cube roots of 2 is 6 cube roots of 2. It's like saying 1x plus 5x is 6x. But over here, square root of 2 and square root of 3 cannot be combined because they're not exactly alike. In the 3 examples I've shown you, nothing looks exactly alike. So we have to simplify each radical to see if they are alike. 8 can be split into 4 times 2, and 32 can be split into 16 times 2. So you have the square root of 4 times the square root of 2 minus the square root of 16 times the square root of 2, which is 2 root 2 minus 4 root 2, and you get negative 2 root 2. You have your same rules for adding and subtracting integers. So we ended up, even though these didn't look anything alike, when we got them simplified, they were alike. Okay, our next example, we've got a square root of 8 again. So I have 3 square root of 4 times 2, and then times the square root of x squared, times the square root of y squared, times y, or times square root of y, I'm sorry, minus 2x times the square root of 16 times 2 times the square root of y squared times the square root of y. So that's just me taking each one of these and splitting them up like we did above to see if I end up with like terms. And I bet I do. So I have 3 times the square root of 4 times the square root of 2. Let's try to speed this up a little bit. 3 times the square root of 4 is 2. The radical is left underneath. We have an x and a y and a square root of y, which cleans up into 6xy. So there's that term, together give me 6, and then xy. And then left under the radical is 2y. And I'm running out of room, so let's see what we end up here. So this is this term brought down, and then this is going to be this one brought down. So I have minus 2x times 4 times square root of 2 times y times root y. So I've got 6xy square roots of 2y minus 8xy square root of 2y, and we get negative 2xy square root of 2y. There we go. That's number 2 done. And then the next one is dealing with fourth roots. And so anytime the root is more, it's a little bit trickier. But again, pull that sheet from 7-1 from yesterday or from Wednesday when you wrote those perfect squares down. And so with the perfect fourth power, you've got 3 times the fourth root. So 2 to the fourth is actually 16 times 2 times a to the fourth times a. So you see where I split that 5, and I was looking for things that matched. A fourth power, and a fourth root. and then minus a times, oh wow, fourth root of 162. I think I have on there that 3 to the fourth is 81. So that's going to be 3 to the fourth, there's our 81, times 2 is our 162 with an a underneath. So I have 3 times 2 times a, when I bring those two out from under the radical, and then what's left is the 2 and the a. And then here I have minus a times 3 times the square root of 2a. So because I have the square root of 2a in both of them, I have 6a root 2a minus 3a root 2a, which equals 3a root 2a. Yay! All right. Multiplication is actually a little bit easier because you can do more with it. You cannot multiply unlike roots. So here we have a cube root and a square root. Here we have two square roots, so I can combine what's inside and get square root of 6. Sometimes you want to do that, sometimes you don't. To be honest with you, I don't want to multiply 8 times 32, which is what the first example is suggesting. I'm going to split square root of 8 into 4 times 2, and I'm going to split square root of 32 into 16 times 2. And then pulling this out, the square root of 4 is 2 times root 2, and then the square root of 16 is 4 times root 2. So I have 8 times root 4. So here's where I'm using that property that the square root of 2 times the square root of 3 is the square root of 6. But here I'm doing the square root of 2 times the square root of 2 is the square root of 4. But we all know that the square root of 4 is 2, so 8 times 2 is 32. So when you're working with numbers, sometimes it's easier to break it down, because if we had multiplied 8 times 32, actually 8 times 2 is 16. If we had multiplied 8 times 32 and gotten 256, I don't know about you, but my bet is that you don't know that the square root of 256 is 16. So if we take it little pieces at a time, we can get our answer. When you're dealing with just variables, I think it's easier just to go ahead and combine them. You've got the square root of x to the second times x to the first, adding exponents is x cubed, and y to the fifth times y to the first, add those is y to the sixth. So you have the square root of x squared, the square root of x, the square root of y squared, and y squared. So pulling out what we can, we have 1x in front, 3 y's, with a square root of x left over. Okay? And then this last one, which is a combination of cube roots of constants and variables. Cube root of 2, and then let's look at our numbers. Let's put our 4, our 2, and our 8 together, and we'll deal with everything separately. In fact, I'm going to pull that away. And then cube root, let's add up all those a's. We've got 2, 3 is 5, and 5 is 10. 1 and 2 is 3, and 6 is 9. So b to the 9th. Okay, so here we have cube root of 64, which is actually 4. And then taking our cube roots, we have an a cubed, an a cubed. There's counts for 6 of them. There's 9 of them, and 1 left over. And then here, the cube root of b to the 9th. So we have cube root of b to the 3rd, cube root of b to the third, cube root of b to the third,